Welcome back. So now we're going to have a roundtable on the impact of technology on social sciences, disciplines, and research. And we're very pleased to have four wonderful scholars, Santiago Barreda, Assistant Professor in Linguistics, Amanda Geyer, Associate Professor in Human Ecology, Faculty in the Center for Mind and Brain, and Chancellor's Fellow, Duncan Temple-Lang, Professor of Statistics and Director of the Data Science Initiative, and Cecilia, Associate Professor in History. So I've asked each one to lead off by describing some aspects of how technology has changed their discipline and research, or how it has come up with in their interactions with others. My provocation to them included the following. I suggested things like changes in research methods where new questions can be asked due to computing power, large databases, new types of analytics. Second, changes in evidence indexed by new techniques leading to new subfields or fights within larger fields. Three, new forms of presentation, such as visualization, in which some fields have led to questions of authorship and even tenure. One of my projects as an anthropologist of science was that in biology, the person who did the visualizations often becomes an author on the paper, even if they don't have any wet lab experience. And then this has shifted to, can that person get tenure in biology? And fourth, struggles over resources due to things like fMRI machines. In a school of education where I once collaborated, it was said that one could only get funding for projects if they involved brain imaging, leading to resentment and grudging use of it. Just the power of what granting agencies are interested in can then drive research questions or shape them. Curriculum changes in undergrad and grad as these technologies and other tools supplant older ones or require new space in curriculums. Where there's no space, and new types of interdisciplinary collaboration emerging, both big opportunities and big challenges in grants, publications, and promotion. So, Cecilia, we'll start with you and just move down the line.
Okay, well, thank you. I'm really delighted to be here, and it might be appropriate to start with history because I think compared to many of the other social science disciplines, I think historians are unabashedly low-tech or on the low-tech side. Historians are mostly self-taught when it comes to using technology and statistical analysis and so forth, and PhD programs in history generally do not provide training in this, and our work does not, for the most part, require specialized software or equipment or lab space. And there are exceptions, and there have been pockets of scholars within the field of history who have long been interested in technology and quantitative methods, like demographic historians, for example. And things are changing, so I think it is an exciting time for historians to incorporate new methodologies in their research. And I like what David Henkin said earlier at the beginning of his presentation about the revolutionary promise of technology for historians and how we don't want to miss that party. And so I think this is, there are ways in which this is a good time to have this conversation from the discipline of history. So how I thought I'd approach this topic is to talk briefly about technologies that I think facilitate our research as historians versus technologies that change the kinds of questions we pose in our research. And then I'll just provide some examples from my own research that illustrate this. So in the first category, I think about technologies that have made doing historical research easier, basically. So things as simple as digital cameras, so we can take images of documents in archives that allow us to go through materials faster, not rely on prohibitive photocopy requests. And so these are technologies that are important for our work and widely used across the field. They allow us basically to be more efficient and productive. And I would put in this category also things like searchable digitized databases, which include census records, and that are really vital for social historians like myself who are trying to recover basic information about people who did not leave much of a written record, like Asian immigrant farmers and farm laborers in the Santa Clara Valley who were the subject of my first book. And I'm thinking of a tool like Ancestry.com that you might have heard of. It's used by genealogists. It's developed for them in large part. And that came of age when I was in graduate school, and it revolutionized how I collected data on Asian immigrants in Santa Clara County. I was looking at the period roughly 1870 to 1930. And I started out in grad school going through microfilm of what's called the manuscript census, the decennial census, taken by the federal government. And so I had 2 reels that pertain to Santa Clara County, and I would go through them and look for, by country of birth, I would look for Asian last names, and I created this database of Asian residents of the county in that way. And this includes also information like occupation. So I was interested in farming, and sometimes it would list also what crops they were farming and so forth. And so obviously with the advent of something like Ancestry.com, that made things a lot faster and easier to get through once that was digitized. And it also opened up the possibility of searching for specific individuals and families by name that would have been virtually impossible with microfilm. And so with using the census and then other sources like lease records, crop mortgages, property records, certain Japanese language sources like ethnic newspapers and directories, that allowed me then to construct very detailed family histories and chronologies to examine family formation, patterns of farming, and how they changed over time in response to legislation, changing concepts of race and so forth. And then another example of digitized databases that have facilitated historical research that I think are used really widely by historians are digitized print media databases. So these are things like ProQuest historical newspapers. So you're able to then search for exact terms as they appeared in the original sources. So I could plug in Santa Clara County or Japanese immigrants or something like that, and then come up with all of these search results. And the range of periodicals that are covered in these databases is really growing by the moment. And it's really, in my new research, it's on the 1970s and 1980s. And so I definitely have taken advantage of sources, like along with ProQuest, things like Access World News for local and regional US newspapers, LexisNexis Academic, Factiva. And so with these databases, historians can cover a wider range of array of sources, and find more relevant documents and not be chained to microfilm as in the past. So, and a couple of caveats about this. I think there's the qualitative aspect of historical research, in my opinion, still cannot be replaced by technology. So just to give a quick example, I think I find that I'm still missing things in these targeted digitized searches, where the results are only as good as the search engine, and I know the reference librarians especially have various tricks for optimizing searches, but I still find that I often miss things, and I have no idea why certain obvious pieces do not come up in search results, and then I've found them some other way, like in an archive, or referenced in another source. And then also I think there are ways that the old-fashioned method of combing through newspapers on microfilm or in bound volumes is still beneficial for getting a feel for the locale and the time period, for coverage of other issues and seeing things that you didn't know you were looking for. So I know when I was looking through these non-digitized trade journals. So these are published by California farmers in the 19th, 20th centuries. I was looking through them for mentions of Santa Clara Valley or Chinese and Japanese labor. And in that, I came across multiple references to Hawaii that led to another research project, a side project on the connection between the anti-Japanese movement on the mainland and the depiction of Hawaii as the prototype of the ominous majority Asian place. And so I probably would not have found these references if I had only done targeted searches in volumes and gotten results about where these terms appeared. I wouldn't have been looking for Hawaii. So anyway, so that's the first category, technology that I think doesn't necessarily change the type of research we do and or how we approach our subjects, but certainly makes our work easier. Then the second category I want to talk about is technology that I think has changed the kinds of questions historians ask in our research and allow us to ask different kinds of questions. And there are a number of these technologies, and I don't think there's one that everyone is using or going towards using. And I just want to give 2 examples that I'm currently exploring in my new project that I don't have much experience with, actually, and I'm looking to other social scientists for guidance. and advice. So basically, the book project I'm currently working on examines the evolution of Southeast Asian refugee resettlement policy from 1975, the fall of Saigon, to 1990, and how that intersects with the rise of modern conservatism. And there's been a lot of, or more scholarship on US refugee policy and debates over admissions of refugees, ideologies of humanitarianism. There's also some great new work on refugee camps as these in-between transitional spaces. But I found that there's very little about what happens to refugees after they are admitted into the US. And obviously you've heard about refugee issues that are prominent in the news today about Central American child migrants or North Africans arriving in Europe, and there's a lot of discussion over whether the US or these various European nations have an obligation or should admit these individuals. But in the case of Indo-Chinese refugees in the 1970s and 80s, for the most part, there was widespread consensus among American officials and the public that the US needed to accept these refugees who were US allies during the Vietnam War and acknowledge that there was American responsibility towards refugees from Vietnam, Cambodia, and Laos. And so accepting the refugees wasn't the main debate, but it was resettlement, or how to integrate or incorporate these refugees into the nation, how to not have them remain perpetual burdens on American taxpayers was this big question. So I'm looking at how Southeast Asian refugee resettlement policy fit into a period marked by conservatism and mounting skepticism towards the role of government. This was after Vietnam, after Watergate, with the election of Reagan in 1980, and how resettlement became a contested and convoluted undertaking at the federal, state, and local levels. And so one approach using technology I wanted to kind of integrate in this project is mapping, or spatial history. And so GIS, or Geographic Information System, as many of you know, this is a system for marrying data sets with geography, and it does fundamentally change how historians, I think, can conceptualize spatial information. So in my research, where this would apply is that in examining patterns of migration. So the current scholarship is based on this assumption of the failure of the federal government's policy of dispersing refugees. So this was known as the scatter or broadcasting approach, that the federal government would place people in various places all across the country. So the Hmong, for example, were resettled or were assigned to 53 cities in 25 different states. And so scholars have noted that this was a failed approach because what happened is you get secondary migration, and refugees would then go to other places that were more where they wanted to be to reunite with family members and members of their community. And so you would get these concentrations of refugees in places like California, the Central Valley, or in Minnesota in the case of the Hmong. And they were pointed to as these problem spots. But the exact nature of patterns of secondary migration, how it worked over time, is not well understood. So I think that's where mapping could then reveal new insights on the geographies of resettlement and migration. There is a possibility for mapping other data besides population. Like I'm thinking of, like, for example, mapping kind of welfare payments for states or areas where the Office of Refugee Resettlement planned secondary resettlement programs and how that changed patterns of migration, industries of various states that kind of maybe made it more, provided better opportunities for refugees to settle. And so anyway, so I think I'm thinking about that as one possibility, and there are certain logistics that would have to be overcome, that I would have to construct the appropriate data sets to do this mapping myself. And then finally, the second approach that I'm thinking of for this new project is lexicographic analysis. So I'm sure linguists can definitely explain this better, but it's a form of humanities computing. And so digital lexicography would allow for tracing discursive evolutions and shifts over time. So, and so scholars can create these customized, searchable databases of digital text, so they can either draw from millions of texts that libraries have already been digitizing, or then you could make your own text via scanners, digital cameras, OCR text recognition software, and then use statistical software to then see broad discursive trends. in language, and so you can then quantify the rise and fall of certain words and phrases geographically and temporally. And so this has been done in comparative literature and by literary studies scholars. And I don't think it would replace historians' close, nuanced readings of complex, often paradoxical texts. That's really at the heart of what historians do, but it's a way to kind of it's an adjunct to this discursive analysis. And so applied to my research, I would see, I think what I would focus on is this term self-sufficiency comes up over and over again in the stated goals of resettlement officials at the federal, state, and local level, and by private agencies, these VOLAGs that would resettle refugees. And what they mean by this is finding self-sufficiency, is finding remunerative employment for refugee families so they would not become or remain welfare dependent. And so I make an argument in this project that the principle of economic self-sufficiency as the overarching goal of refugee resettlement produced increasingly narrow views of successful outcomes. And so resettlement policy became stymied by these fears of wasting government resources on social programs. And so I think an analysis of the rhetoric surrounding self-sufficiency would be fruitful. So it'd be possible with these technologies to compare rates of usage of self-sufficiency among private and government agencies, also how refugees themselves use the term. I've come across many letters written by refugees to agencies, their own newsletters, their own mutual assistance associations that use the term self-sufficiency. I could see it being juxtaposed with other terms like welfare dependence, economic independence, self-support. So I think this would be a useful tool to analyze rhetoric and to quantify the prevalence of it beyond just saying that it was a term that was used often. So being that I could try to trace how does it peak during the 1980s, does it decline over time, and so forth. So those are just some of the things that I'm thinking about. And there are other examples of technologies that change the nature of questions historians pose that I don't cover in my own research. There was a recent issue of the American Historical Review that talked about the history meets biology, and so kind of the intersection of history with evolutionary biology, with neuroscience, with these other disciplines. But I'll stop there, and yeah, thank you.
I want to talk more to you. Okay, so I'll just plug this in. Well, I just got the talk that I wanted to hear today. This is exactly what we are trying to do, is to reach out to people in different disciplines where we can actually make a difference. This will come up in a second. To actually help people do different things. Okay, I'm Duncan I'm the director of data science. So what's data science, very quickly? It's everything from accessing data, acquiring data, cleaning data, visualizing data, exploring data, modeling data, small part, but a very significant part, conveying the results, okay? It's the whole pipeline, absolutely everything. So it's computer science, and it's statistics and domain sciences. So that's what we're trying to do, and it's challenging, but this beautiful stuff that's going on here, it makes me very excited. So I'm going to take a much bigger picture because I'm not a social scientist. I'm not going to tell you how things matter in social science, but it's more like what can we do to actually get more interdisciplinary work, and what are some of the questions, and I hope to provoke a little bit of thought because we're facing some big challenges in the university, every university. So what do we actually think we can do? I believe we can ask new questions, brand new questions. There are new research agendas to be actually had because of the availability of new data sources. Okay, we can do all the same things, but we can do new things, and we can do existing things and new things in qualitatively new ways. And that's so just exactly like digitizing documents and being able to search them in different ways and being able to map things and be able to visualize things rather than actually just describe them in prose. And so we can convey results differently. How do we do this? Again, this is a very short overview, but it's interdisciplinary collaborations. This is at the heart of so many different things. It's so hard to do on campuses. It's so hard to do with funding agencies and so forth. But it's exactly what's going to actually happen to actually make these new things realities. Unfortunately, These involve computing, data technologies, data analysis, inference, visualization. When I wrote these, I was very careful not to use any term that referred to anybody's field. And there's no statistics, there's no computer science in here. These are very applied skills that everybody needs that are not actually academic skills, that, you know, where you actually are going for PhD degrees and so forth. These are actually skills that many, many people need, and we actually think these are akin to reading and writing and arithmetic. Okay? They haven't been taught, but we've got a really serious issue. That might change in about 10 or 15 years as things get into the K through 12, but for the moment we've got a real problem with people not knowing how to do these things. And this is an enormous big opportunity of actually fusing different data sources together and integrating auxiliary data to be able to answer qualitatively new questions. Okay, huge. I'm very happy to hear it. You just mentioned biology at the end. You know, there's text, there's images, there's movies, there's all sorts of different sources, and genetics and phylogenetics and all sorts of different information that we need to be able to pull in to actually get a richer sense. Maybe they won't answer. Maybe they won't change the results of our questions, but they probably might, and they certainly will actually lead to more confidence in what we actually have. So one of the things, the very simple thing, people need to know about computing and so forth, but they also need to know what is possible. Okay, this is a hard problem, and people have come to me and sort of said, oh, I didn't know you could do that at the end of the conversation, and it's like, and we need to have those conversations. We can do an awful lot about digitizing text and being able to make searches better and being able to find outliers in clever ways, and we can customize these things and to different applications. So I'm here to pitch something else as well. So how do we solve this? We can't solve the training problem now, but we have to do it. We have to start, okay? But we can actually do interdisciplinary research, okay? And that means we actually have to be open to it. And fortunately enough, I'm the director of this data science initiative, whose task is to do this, and we have some minimal funding to be able to do this kind of for free with you, and we are looking for active collaborations for doing data science related tasks. But at the same time, sort of, we actually do need to train social science researchers to actually be capable, not experts. We do not want them building the next Facebook. We want them to be able to manipulate data and not deal with massive scales and engineering problems, but just be able to be self-sufficient in a very different sense, to be able to answer their own questions. That's the longer term. We can actually use interdisciplinary problem solving and collaboration to get here. We can do the education at the same time. Okay, so they need these statistics, you know, all computing and technologies. Most importantly, they need to learn how to problem solve. This is a different thing. We were just talking about this, and it's a very, very different skill in some regards when it comes to technical things. In data science, we talk about pie-shaped researchers. These are people who have legs in two camps. Okay, these are, rather than their single domain, they actually have to have multiple skills. Okay, one thing. So I'm going to sort of mix things around a little bit. One of the things I was thinking about from the perspective of statistics is there's statistics, there's machine learning, there's data mining. These terms have come and gone and changed. Statistics has been around for a long time. Machine learning and data mining were sort of came in through CS. There is a danger I'm concerned about, just with looking at Martin Hilbert's talk today and things like that. I'm worried that Google's going to be able to do social science better than we are. Okay, or you are actually technically. Okay, but we collaboratively, because remember the collaboration, and that is that they won't do it well, but they'll do it, and they'll actually be heard more loudly, and it may be actually quite superficial. And in statistics, people didn't actually respond to the needs of the changing world of machine learning. And I'm just sort of saying, if social science doesn't do this, you know, what happens? Any answer is better than no answer. Knowing that you could get the answer in theory, but not doing it, leaves the door open to many other people to do it. And we can collaborate with these people. That's ideal because they have the skill sets and so on. It's not just the Googles. It's just the computer scientists who are saying, I can find relationships here. But the depth of the relationships may not actually be very significant, and that's an important thing. So you do need the entire pipeline, and this is where data science fits in. So there's opportunities for collaboration. These are all the things. These are the details of some of the details of what people actually need to learn to do some basic domain sciences in history and linguistics and so forth that I think come up over and over again. These are common themes. The big thing is in the one in the green. These are just details. The real is getting an experience, a sense of data analysis. It's unfortunately not very well taught in statistics. I can say this, I'm in statistics, okay? It takes a huge amount of experience, an enormous amount of time to develop, but we can actually do a little bit better, but people have to get exposed to this stuff. So if we're going to teach them how to do computing and a bit of statistics, not massive amounts of statistics, if we're going to do this, as Joe was mentioning, what can we do to put it into the curriculum? Okay, this is my question to you about them. Again, slightly trying to provoke a conversation is, what can we do to actually get more space in the curriculum? Okay, who's prepared to actually throw stuff out? Okay, I've been at faculty meetings, it just doesn't go very well. Okay, and again, we may actually have a potential solution for this. Okay, we may have special students who are just sort of, you know, in a different track, and there's only 3 or 4 of them. Then they're left to learn it by themselves. That's unsatisfactory. There may be 3 or 4 in every department with common needs, and now there's 25 of them, and that actually means a quorum to actually get a class going. Okay, but we need to actually interact in that way and find the commonalities. Okay, and the other real thing is, how do we actually let people go off and do all sorts of wonderful things that are brand new, very risky, and don't stifle them? Carl Stamer, who some of you may actually know, who's the Director for Digital Scholarship in the library just recently, he was telling us about when he was doing his PhD in English, and he was doing all this internet stuff, and they told him it was a fad, and he should move on and do some serious stuff. And he's doing some absolutely gorgeous things these days in data science. Okay, so I just want to mention the DSI because it is a resource on campus that I want you guys to know about and leverage for free. Okay? So basically, we have a very strong focus on broad interdisciplinary research. So we're not academic statisticians or computer scientists. It's not just research, it's also education. Okay? We're actively seeking collaborations very soon, okay, like tomorrow. If you come to me tomorrow, we will start then, okay? Summer is a great time, okay, on both existing and new projects, okay? And they can be massive, brand new, very earth-shattering projects, or, you know, reasonable problems that you can't solve, but you know that somebody else can, okay? And that would make life much better for you, okay? So, in terms of actually getting things done, okay? So basically, as I say, we're very sort of applied orientation, but the research end of things is an enormous component, okay? We want to help people develop new curricula. We want to help people develop new components in data-driven courses. We'll provide workshops. We need to hear from you. We really do, and we're prepared to actually go out and do an awful lot of work because we believe so much in this, okay? We may even develop designated emphases and minors and programs, okay, if there's enough interest. And finding the commonality amongst these different disciplines is important, okay? There's, I'll just say, just quickly say one thing, okay? There's a lot of buzz about big data. A lot of nonsense, okay? I mean, and we just don't want to be lured into this, okay? It's very exciting. There's real opportunities. We need to actually have wisdom to look at this. There's no getting around that. You have to read the data, if you will. You actually have to be with it and experience. And there's a real danger that people will get lost in technologies, okay? There's a huge surge of this. Okay, well, let's all go out and learn Python or R or whatever it is, and actually and forget the question that we were actually asking. So, and the other thing is there's a big difference between big data. There's a lot of talk about prediction, and I think in social sciences, and somebody mentioned this earlier today, which I think is really important, we're trying to understand things, not predict them. Okay, we want to know what will happen in an intervention. We want to actually be able to understand the mechanisms, and this is qualitatively different from what Facebook and Google are doing in terms of actually predicting what ads you'll click on. Okay, there's a different question. Okay, so the one thing I'll say just last is, I've seen this in other disciplines. Embrace it or not, it's a decision you guys are going to have to actually make, and it's going to take time to actually develop the curriculum or not. So, but we are here to help. Sorry for taking so long.
Okay, it's really exciting to be here and to sort of contemplate these items that I feel like sometimes I'm just sitting in my office thinking about by myself. So it's nice to have a chance to articulate them. I conduct research that looks at adolescent brain development, and I try to link patterns that we see in brain function, brain structure, with most typically I've been looking at symptoms of psychopathology such as anxiety, social anxiety, depression, substance use. And as well, I look at age-related differences. So sometimes I'm comparing groups of adolescents with groups of adults, for example. And this has been really interesting for me because in my graduate training, I didn't do neuroscience at all. I was trained as a developmental psychologist, but I found myself with questions that really involved trying to get a better understanding of biology. And so I took this sort of new turn with my work to learn about the brain and to go and learn how to conduct neuroimaging. So I spent almost like another PhD, a 6-year postdoc, gaining some of these skills to try to do this in my work. So it's been very exciting and has absolutely raised lots of problems I need to tackle every day in terms of things, the struggles over resources, for example. Doing this kind of work using fMRIs is costly. Just the hourly fee alone costs a lot of money. There's also issues around being able to access the machine that you need, having staff to help run the machine and people to help you collect the data, and then how to train your students and your trainees on these methods that really draw on exactly these kinds of skills that Duncan was mentioning, trying to process data, visualize data, and solve problems in the patterns that you've got in your data. So it's really exciting to be somebody who's been able to integrate technology into my work because it was driven by new research questions that I had at the time. So that's been a very exciting thing. I think that in my field, you might call it developmental cognitive neuroscience. Really, one of the first studies was published in about 1995. So it's relatively new to use this kind of technology in the kind of work that I do in terms of developmental psychology. And a lot of these studies, the initial ones, relied on really small samples, about 12 kids, 12 adults being compared. And so one of the exciting things that I've been working on in the projects I've had over the last few years is actually drawing much larger samples, not nearly as large as other disciplines might draw on. But for example, I've been acquiring data on about 200 adolescents at this point. And the other interesting thing that, at least to me, is I've been also trying to track change within individuals over time. So a few of my projects now are collecting fMRI data at multiple time points so that I can see, okay, in this set of kids, what's going on in their brain and in relationship to particular symptoms at age 16, at age 17, at age 18, and trying to model those patterns over time. So we might be able to see correspondence between brain and behavior over time within individuals. So that's been an exciting new direction as well. That I feel like now there have been a lot of advances in the software programs that are required to process and analyze fMRI data that now allow us to do those kinds of analyses. When I first started out, for example, I knew I really needed to do a statistical analysis called a repeated measures ANOVA. But the software I used didn't have a way to do that at all. So instead I had to run just a set of separate t-tests. And that wasn't necessarily the best way to approach the data, but I was limited by the software. That issue has now been addressed. I can now run a nice repeated measures ANOVA in the same software program that I had used, 4 years prior. So every day I'm finding these software programs, for example, to be changing, to be updated, to be responding to the needs of those who are, asking these different kinds of questions over time. The other exciting piece to me is that I feel like my work has been moving in more of an interdisciplinary sort of direction, in the sense that I've also become very interested in trying to utilize existing data available on the participants I've been studying, because they've been involved in other studies, and other studies in which the data collected on them is different. It's observations of their behaviors when they were babies or toddlers. It's questionnaires that they've filled out about themselves, their parents have filled out about themselves. It's census tracts so we can understand what neighborhoods they're in, and trying to pull all this together to see, well, what kind of influences are adolescents' environments having in relationship to brain. So that's another exciting direction my work has been taking, and I've been lucky to get to know different faculty, for example, in the economics department through different initiatives on campus. So we come together and talk to each other about poverty, for example. How do we measure socioeconomic status, and how can we do this in the kind of data set that I have? How do they do it in the data set that they have? And what can we gain from understanding these different approaches to better understand how kids develop and in what context and what matters the most for their healthy development and outcomes. The last piece I wanted to talk about, and it's not something that I have used in my work, but it's an area that I have seen sort of burgeoning in the study of adolescent development, for example, and it's generally referred to as sort of sampling daily experiences, right? So ecologically, momentary assessments, and these are done using daily diaries, for example. So kids are asked to report every single day at a certain time of day on things that have happened for them, how they feel, so on and so forth. Or they carry beepers around with them and they're beeped, and then they respond to that beep with whatever question. Or you pull their Facebook pages and you relate that to their moods, to their brains, to all sorts of things. So it's been really exciting also to try to get a little bit more of that micro picture of their daily experience, and doing that with technology. And I've seen in different colleagues I have in the field, I've seen them incorporate these different methods within their studies to try to get this sort of more micro time scale, if you would, of their daily experiences, to integrate that into mental health, for example, and other indices of well-being. So that's also a very exciting direction that I've seen technology altering and shaping the course of research questions being asked in the field. I think that's all I've got, but I'm happy to answer more.
Hi. All right, so I'm here to talk about linguistics. Linguistics is the study of human language. It's very broad. It encompasses things from phonetics, which is just sounds, like the kind of sounds I'm producing right now. So for example, I can tell you something like North Americans tend to be nasal for vowels before an A. So if you say something like man, you can try plugging your nose and see if you sound different. If you sound different, you have nasal speech. So that's not something that most people are consciously aware of, but it's something that most people know. There's things we are more aware of, like the dog and not dog the. So that's something like syntax. And then more complicated than that is something like pragmatics. So if I say, boy, it's cold in here, but what I really mean is, will you close the window? So that's, again, not something that's directly evident in the signal, but it represents language knowledge. So really, technology is affecting all levels of linguistic analysis, and it's doing so in a couple of ways. First, it's making data collection way easier. Obviously, recording people, making video recordings, audio recordings, taking pictures. All of this is much, much easier than it used to be. People's whole lives are being documented these days. Before it was hard. I mean, a lot of us might not have video recordings of us when we were younger because that technology wasn't really widely available. Now people's telephones do that. So documenting things has got much, much easier, but this actually leads to a kind of different problem in linguistics. It's kind of like the dog chasing the car. What do you do once you actually do have all this data? I was thinking about this lunch we just had, and language is a weird thing because How many words were probably said in total during that lunch? Tens of thousands? So we're constantly bombarded and surrounded by language, which is the output of the system we're trying to describe. And yet, what can we actually do with all this language that's happening all around us? So one of the things that people are doing with this is things like building speech corpora. So massive collections of written or spoken data, hundreds of millions of words, for example. So things like corpora tell us, what do people actually say? Not just what could they hypothetically say. So things like how words go in and out of style. Like why is everyone here probably more likely to say cool than groovy? We know that they mean roughly the same thing. Is there like a separate piece of knowledge that tells you not to use certain words that mean roughly the same thing? Corpora, looking at what people actually do instead of what people could hypothetically do, gives us all kinds of information about language knowledge. For example, there's something called semantic prosody. I learned this in when I took my first speech corpora class. Semantic prosody. So for example, the verb cause. Is it bad or is it good to cause? That's a weird question. I think most people would say it's neither. It's making something happen. But I think most people also agree that someone caused an accident, someone caused mayhem. It's weird to cause pride. She caused me to win first place. She caused me to be disqualified. So there's a negative connotation with this that's somehow secret and hidden. These things come out when you look at massive amounts of data and you look at what people are actually doing with language instead of what people might hypothetically do. The thing is, you only have access to this when you actually have this data. Previous generations of linguists could really only speculate. At this point, when this data is actually available, there's really a lot less of an excuse to just speculate. So that's one way that linguistics is being changed. Now you're actually confronted with having to test your hypotheses and dealing with, but the other thing is, you have a corpora with several 100 million words. What do you even do with that? So that's one of the major problems of kind of having your wish come true and getting access to all this data. At a more low level, there's things like actual computer speech representation, which involves digital signal processing techniques that rely on advanced computer power. Like I learned signal processing using a book from the early 90s, which wasn't that long ago. And a big focus of the book was how can you minimize RAM usage during what today is an operation that would be a joke for a watch. So, for example, now we can do things like digital signal processing and communicate with computers in real time. Things like Siri exist, although they're not really as good as you might think they are. Apparently, Siri relies on sending speech to a server farm, and that does the processing. So that kind of leads to another way linguistics is changing, which is the different kind of data that's being generated. So things like Twitter, which gets brought up a lot. There's Twitter corpora. What are tweets like? Or text messaging. How does text messaging affect language? So a lot of people might see text message language or chat language as like a sort of broken or disorderly manner of language use, but it's not. It's just a different kind of order. The other thing is, I think when we watch movies about the future or Star Trek or whatever, a lot of people's conception of what the future means, whatever the future is talking machines. I think in a lot of movies, especially like when you have sentient robots or whatever, usually you want those robots to talk. You rarely see a science fiction movie where a computer gets sentience and is running around killing people and actually can't speak. Speaking is like the signifier the filmmaker uses to tell you that this is an intelligent thing on par with us, something to be feared or whatever. But apart from that, I think we'd all like to see a future where we can actually build talking machines and have interaction with artificial intelligences. And, when you're trying to solve a problem like flight, whether something flies or not, the constraints on that are physical. You have to understand the physical universe and overcome the obstacles imposed by that to make something fly. To make something talk, though, the answer's in here. The constraints are placed by human psychology, and humans almost definitely present the optimal solution to the speech problem. So that's sort of one thing I answer to people that are particularly pragmatically minded when they say, why study linguistics? I sort of just respond that, like, wouldn't you like to get in, like Star Trek style, to your house and say, kitchen, boil some water for me, So in closing, I'd just like to say, not only is it affecting the research and the data, but it's really it is going to more and more open up more and more avenues for useful research in linguistics that has practical implications for everyday life. Cool.
Okay, thank you all very much for such great provocations. So we had these presentations specifically short, so there could be more time for dialogue among you all. So we have some microphones in the room, and I'm sure they have more to say if there aren't questions. Silence them. Sorry, let's just get the microphone to you.
Excuse me, sorry.
Drew Hoffman from Sociology. So I've been doing some stuff, sort of like content analysis, discourse analysis, things like that. You know, I use these corpora, I search them. Again, the searches are always messed up. There's a bunch of weird shit that's not where it should be. So that's one problem. But then another problem is like, you know, I start counting references to a certain term, et cetera, and then at the end of this, and when I'm done with it, I'm kind of like, yeah, so what, right? And so I'm really much more qualitatively inclined, right? So I guess the question, this is a long preface, but the question is really like, you know, what are the tools that can allow, I'm really excited about all this data, but I kind of want to use much more still qualitative ways of interacting with it. And so I'm interested in how technology could aid that.
So can you hear me? Yeah. So one way, it's hard. This is one of the reasons I mentioned about data analysis actually taking a lot of time. You actually have to know what the questions are, and then you actually have to think very hard about what the data are going to admit to. But one of the things you can actually deal with is, you both of you sort of said, these searches, that things end up in the wrong place, they're just crazy searches. You're finding out outliers. You are actually finding anomalies in the data. And if you can find a good way of identifying these, you may actually be able to eliminate those documents or actually correct those documents or finding out something interesting about those documents. So in that regard, actually just using data summarization to explore your data and get the quality correct or to find things you didn't expect, that's a big issue. I fully I mean, at the end of the day, on the qualitative front, I mean, everything is qualitative to a large extent. I mean, a lot of statistics is very boring because we estimate parameters, and then this is a big difference. Joe and I are working on this in classes, which is, what do you do with the numbers that people estimate? That's the interesting part. And why did you estimate them in that particular way? There are a lot of statistical techniques and models that will allow you to address different questions and then get the qualitative answers that are a little more objective than that. So you can actually say this isn't entirely subjective. And that might be the case. But again, it's very much framed in what the questions are and what makes sense to ask of your data.
My question was raised by something Cecilia was talking about in terms of using technology to access this data, and you were describing the evidence or the data that you had been using previously and how it's idiosyncratic and, you know, census records taken by hand or just made by fallible human beings. And I wonder, both for you and for others, to what degree does the technology highlight these qualitative elements that go into shaping the very stuff you're then quantifying, and to what degree does it hide it or illuminate it? In other words, does applying these technologies reveal or conceal the messiness and the kind of act of faith you're taking anyway of pretending that these are units that can be, not pretending, but deciding that these are units that can be measured and manipulated, and right, that the technology itself, what role does it play in your understanding of the original material, I guess?
Yeah, I think that's a good question. In the case of the census databases, I'm not sure exactly the tools, say, for example, Ancestry.com has for transcribing the handwritten censuses, but there's somebody who's doing that, or there might be software that's doing that, and so it could be. So it's like whether I'm doing that by looking at microfilm or the software is doing that, I'm not really sure what's more accurate or what it illuminates. I think the rate of error, it could be comparable, or we could be making different kinds of errors. So, so there, it's like I think it's the same issue whether you're using and similar with this. With OCR, I don't know if you've used that, but it seems like there's this accuracy issue too. Like, is it accurately digitizing what the text says? And I haven't had experience with that, but I would like to hear how that works. So I think I don't have a good answer to that, but I think that there definitely it's the technology is not the answer to the problem of idiosyncratic data. Errors that are inherent to it.
Sorry, there is one aspect where it can help, and that is actually, well, the OCR, or whatever automated technique is actually being used. We can then find the errors. By actually having humans go back in and check the errors, we can actually then retrain the system, okay, and actually improve those errors. So in an awful lot of cases, off-the-shelf OCRs and other things work as well as they work, and that's the end of it. At the moment, which is the one case where it's blatantly clear how it's failing, and we get data as how it's failing, and then actually go back and change the algorithm, and we can actually get it pretty well. So the combination of the two is cool.
Hi, Georgia Zellu, Linguistics. So Santiago touched on a really interesting point that in linguistics is really big, where access to technology, access to corpora, access to big data has basically revolutionized the field, has basically allowed scientists to ask different questions, to examine questions that were previously asked, and led to sort of a revolution in the field. And I wonder if the specialists from the other areas could speak about this in their fields, whether technology and this kind of the growth of technology has led to sort of theoretical paradigmatic revolutions within their fields. Thank you.
I think one outcome in my field is the data that has been collected using neuroimaging, for example, particularly of structural brain regions and how they change over the course of development. We had a real shift in the idea that, originally a lot of scientists in developmental psychology would sort of say, okay, well, most of the brain development is done by age 3 to 5, but some of the findings from some of these large-scale longitudinal studies of changes in brain structure really actually showed that the brain is continuing to develop into the early 20s. For example, the prefrontal cortex. So that finding alone has dramatically shifted the way people think, has really opened up new doors, at least in my field, in terms of, it's not all done very early on. And then that has implications for, the legal implications, for example, of adolescents' behavior and things like that. So that's been sort of a revolution, I would say, in my field with technology.
Maybe I can I just wanted to add something to this. I was really struck. I mean, it came up in all the talks, when Thomas Kuhn defined a scientific revolution, like a paradigm shift, he said what it really came down to is that new things counted as evidence that didn't get counted before. And what all of you touched on and Duncan emphasized is, what does it take to retrain our colleagues or train our graduate students or train the next generation in understanding what it means to make a claim based on machine learning, what it means to evaluate someone else's GIS map, what it means to show someone, because there's these two things that kind of work side by side. One is we develop like new journals. So you get a journal of like computational linguistics, and then everyone in that knows this. But then the other part of linguistics might not know in any way how to even read those papers or evaluate the findings in them. And so there's, in some cases, historically, those disciplines split over things like that. Or, in case of anthropology, they just don't talk to each other very much anymore. But I'm interested because this one, the hype kind of leads the innovation. It's interesting because there's like more of an attempt to dialogue about it. There's more of an attempt to say, I'm very curious and suspicious at the same time. And so I think kind of reaching out to this shift that's kind of, we can name, you're not supposed to be able to name paradigm shifts when they're happening, but the temporal flow here is getting disrupted a little bit. And so I think there are these ways in which, each of you has been narrating how you kind of were pulled into thinking differently about evidence. And then the second challenge is then how do you kind of push that out to help your colleagues understand the nature of your new evidentiary claims. I don't know if there's something more you can add on those lines, but I'd love to hear it.
I guess what I would say quickly is I still think, for me as a historian at least, the qualitative nature of the work is still primary. I think what some of these technologies lend, whether they have revolutionized the field, I don't know if I can, if I feel comfortable making that claim.
Fighting words.
But I think it's definitely allowed projects to be more multidimensional, and the conclusions that historians can draw to be much more layered. So especially if we're thinking about something like mapping and seeing spatially. A great example is that we just hired a new colleague, Greg Downs, who has a new book out on Reconstruction and the aftermath of the Civil War, and he's got this great site that looks at mapping occupation and shows that presents the spatial history of the U.S. Army after the Civil War, and so you can really see the kind of the reach of the U.S. Army in the South, and I think it does lead to just more nuanced understanding of what happened immediately after the Civil War, so anyways, I think there are ways in which these technologies really enrich what we're doing, even if the arguments that we're making rely still on qualitative readings of the sources.
The change in terms of linguistics with technology, it's not really splitting it so much as you could see it as like progressing up, since linguistics deals with sound on one level, that's directly observable. It's easy to deal with. Basically, since digital signal processing in the 70s, especially with computers, people studying speech sounds have no excuse for not directly observing things and analyzing them empirically because sounds are out here. But as we can collect more data and have more computational power, more sophisticated analysis techniques, slightly more complicated linguistic problems can be dealt with computers and things like that. But it's going to be a very, I wouldn't have liked to say 100 years ago that we'll never put a guy on the moon, but it feels like it's going to be a very long time before we have a simple, concise computational explanation for something like semantics, how you extract subtle meaning from a sentence. So people in linguistics in those fields, it's completely understandable that they're not being changed dramatically by technology. So in linguistics, I think it's more split, like in terms of how accessible the observations are and how much you could realistically be expected to involve technology and data collection and more sophisticated analysis techniques in the thing you're actually doing.
So I have sort of a pragmatic question. It seems like collaboration and interdisciplinarity is one of the recurring themes. And you mentioned a 6-year postdoc to learn the technology. Learning these technologies it's time intensive, right? And so if in your PhD training you're learning the technology, it means you're sacrificing some of the disciplinary knowledge, right? I think that's intrinsic, or we're doing really long postdocs or whatever. So I'm wondering if, in a pragmatic sense, in collaborative teams, how advantageous it can be to have like a high variance in the technological versus disciplinary focus of the researchers? Would you rather have a bunch of pie-shaped researchers on a team versus having some more specialized technologists and some more disciplinary-oriented folks? Both for the quality of the research and then for professional advancement too. Are there traps to watch out for with regard to adoption of technology?
I loved my postdoc. It was really great. But anyway, it's great here too. So I think that it's interesting. This is an issue that comes up a lot, particularly as I've been participating in some different interdisciplinary groups, and it can become hard, I think, for trainees to know where their place is in a field and know where they should be publishing and what they should be creating themselves as in terms of getting known for a topical area versus some kind of technological skill set. But so long as you're marrying those two, I think that's likely to be a very strong way to go, so that one isn't in isolation of the other, particularly along an academic path in some ways. So I think that they are real issues that trainees I work with kind of come up against. But I think also if you think about if you're starting on projects and you need people to work with you on these different projects, there are ways to support those projects by pulling different people in, different disciplines, different skill sets. So it's sort of a different level perhaps than the kind of direct, you could work with your trainees on specific within field kinds of things and then have some outer supports on specific projects, for example. That might be one way to do that.
Do you want
From my experience in linguistics, I'm probably extremely biased in this because I lean more the one way, but I've found it's just much, much harder to acquire the technological or statistical or analysis or data collection techniques than the theoretical aspects, which you can just read. Most people can, no, but I mean really, I think most people can just read. Well, it's things that you can do on your own, sort of, where the other things are hands-on. It's trial and error, and sometimes no amount of reading, at least in my experience, no amount of reading helped me understand some of these concepts. And it just took time more than anything, whereas the theoretical aspects, I think that most grad students can pick these things up even on their own. Like a lot of research is done alone without direction. So just from my own perspective, I'd rather have a couple of people working on a project who can handle these complicated things that can't be picked up, in a short amount of time. Or at least most of us don't have the ability to pick these things up in a short amount of time.
This is music to my ears. We do actually teach a lot of courses that are in textbooks, and then this stuff, the computing and the statistical practice is actually not in textbooks. It's just the methods and the actual how-to. So it's bizarre that we invert this. We can actually try, again, I'm making this pitch we will teach people these skills if you come to us, or if I can come to you and identify commonalities so that we can amortize it over more than 3 people, and I think they are very common skills. As for the pie-shaped people, it goes back to what I was saying about this is the same as reading and writing and arithmetic. We want people to have basic computational skills so that they can actually self-start, that they can problem solve and not have to wait for 3 days for somebody to come in. But we do not need everybody to be a data engineer or a statistical guru, but they should have some facility so that they actually know what's possible and and how to get themselves out of trouble enough, or know when to go and talk to somebody. That's actually a big deal. And if they don't actually have the same vocabulary, that's a real issue. So they have to actually learn enough of that. And as just one last thing is there's these RISE grants on campus, and there was a RISE symposium, and one of the messages coming out of that was this is suicide as a young faculty member to actually go and be a very interdisciplinary person, and that's a real shame, but it's a reality that we have to deal with. At the same time, it also makes you very unique and makes you very, very attractive towards lots of people. And if it's an academic job, that's one thing, but if it's an industrial job, you better know these skills. So there's a real tension at the moment that we're going to have to actually deal with.
Colin Cameron, Economics. So I'd like to follow up on that. I think in medicine was willing to subcontract out to statistics, right? And the issue, and Duncan now is trying to reach out, right? An issue I think is whether statistics can do a similar thing for social sciences. And I speculate, for example, whether the sorts of people who get into statistics come from more of a sciences background, and that social sciences is a bit more of a stretch.
Two things. It's not just statistics. This is all of data science. So this is the whole computational pipeline. So, and Colin, you know this just more than I know. So that's good. I mean, I do worry that statistics. There's a lot of people involved in social sciences in statistics disciplines, but it's much easier to actually be dealing with harder science, and that's so we need to actually attract and educate statisticians who to go after some of these problems. Personally, I think there's an awful lot of low-lying fruit to actually be had, and that's why I think we can attract it. But it's really a meeting of the two minds of people saying, I want to do more quantitative stuff, and again, not to lead to quantitative results, but to lead to qualitative results through quantitative methods, and then the statisticians meeting in the middle, and the computer scientists.
Yeah, one of the things that fascinates me about this, I could say all the projects represented here, is that in this kind of quantitative-qualitative divide, which usually was defined by statistics as the quantitative side of things, that data science actually seems to sit much more in between, maybe even a third type of literacy, in that it's incredibly obvious to anyone who struggles with the corpora that if you're not qualitatively approaching it at the same time that you're quantitatively approaching it, it's useless. And so that, as an anthropologist, when I hang out with people doing data science in various ways, I hear a very different type of talk in which qualitative and quantitative doesn't in any way hold for any length of time, in that it very different than the way in which the statistical analysis often ends with a number. And then that's the end, and that data science often doesn't. And so that makes it very interesting, I think, for thinking about what interdisciplinary work means when multiple people are in a conversation, and what a kind of other types of future forms of evidence and argument making look like. I think we had a question here. Kara? Oh.
Hi, I'm Xiaoling Shu from sociology. The traditional model of research is primarily confirmative model. That is, you have a theory, and you come up with hypothesis, and you build the model, and then you focus on model building, focus on the few predictors. But then the new type of research give data more power. So you have data mining and unsupervised learning, those types of new techniques that traditionally in the social sciences, many people would have serious doubts against data, quote unquote, data-driven type of research. So how we how we persuade the people who are trained in the more traditional paradigm of research, sort of persuade them to accept that the findings are valid and powerful, and not just some patterns that emerge from this one data set, or just That's probably my question.
Well, I don't know, luckily or unluckily, it depends on how you look at it. Purely descriptive work has been a part of linguistics really from the start, so there isn't really that problem. A lot of people only describe dialects or social aspects of language or sound, how people convey identity, or, like the way we choose to speak really is mostly to tell other people what kind of person we are. So when you look at it like that, with languages like a social tool, sort of, just describing, it's not just describing anymore, it's actually just explaining how this message is being transmitted from one social group to another, from one dialect to another, etc. So actually, for some aspects of linguistics, that's an issue, but generally in the field, a lot of people do exclusively descriptive work or qualitative work without really even testing any hypothesis at all by design. So it's, yeah.
Well, I would just say real quick, it struck me what Santiago was saying about how in linguistics it's like this data is there, so you can't ignore it. It's out there, and you have to test these hypotheses. And I kind of see that within history is that, we don't have so many ready-made data sets for people to manipulate or mine, but I think increasingly as data becomes available, it just makes sense for historians that if this is in your field, it relates to your work, that you have to do something with it. And so I think just at that really basic level, kind of incorporating these new methods and technologies is going to, it's something that we're just not going to be able to overlook anymore.
So I have mixed feelings about this because there's this whole fourth paradigm, data-driven discovery, and it is very exciting, and there's no doubt about it. It's very legitimate, but it doesn't mean that all findings are correct. There's a lot of problems with this. So one has to, as statisticians, we're trained to be incredibly skeptical, and that should only get heightened by everybody. Some of the stuff that we saw earlier on today, so relationships that Google finds, we've got to be very careful about what are the actual real confounding variables. And we've got to be able to validate these conclusions on another data set, okay? And we've got to figure out so if we will always find the biggest correlation. There has to be a biggest correlation, period, okay? And it may or may not be significant, but how many tests have we done? So one of the things that we talk about in statistics is multiple testing. So, you were talking about doing multiple, the reason we have these repeated measures is because you can't do 1,000 tests at 5% level and expect them to get a 5% answer. And if this is all mumbo jumbo, it should be, okay? That's because that's just nonsense. In terms of this is all how we do things, it's not qualitative. So you have to be able to figure out can we validate this somewhere else? So they can be hypothesis generating techniques, not validation techniques, unless you go to a different thing. And we've got all of these other issues. And one of the biggest problems we have is all this data coming from, and I'll pick on this because it's easy, okay, it's Facebook or history. You read certain texts. These are biased samples. These are not the entire population. You better know who you're making inferences about. So everyone should be skeptical. At the same time, that's how we're going to actually find new things. And then we go and study them. So instead of us coming up with a conjecture and finding data and then figuring things out, we can find the conjecture in data, then go find other data, and then maybe confirm things, in my opinion.
I guess this is a question about the data science initiative. So one of the things that we find is different disciplines have different measures of what they consider success. So some areas, it's X number of publications. Some areas, it's like a book written and published. So when you bring together people from different disciplines, what are your thoughts on how would you measure, say, a student in this initiative's success? How do you determine, and more importantly, if you decide it's, publications, where do you send those papers? And I guess it's more a question about, do you have thoughts on how to handle this?
Anyone got any technical questions? So, you asked about the data science initiative. I'll tell you, I come with extreme prejudice. I was at Bell Labs, which is the research arm of AT&T and Lucent Technologies, which was a big monopoly of many years in the telephone industry. We had a wonderful research where the laser and all these and the transistor came out of. We were explicitly told, or aimed at actually, looking for 10-year results, 10 years in advance. And we were so, if you wrote a paper by yourself, that was good. If you wrote a paper with your colleague in your department, that was better. If you wrote a paper with somebody in a different department, that was success. Okay, so we have that's a very different culture in academia than in Bell Labs and IBM and other places like this, and we've got to deal with that. It's a real concern, a very, very real concern. It goes back to what Michael was saying, like, do I want these different people? It depends where they're going. If they're going into industry, then they're successful if they become very broad. And that's useful. One thing we can't. I can't answer that because because it's somebody else who's going to evaluate these students and faculty and so forth. But it is one of those things. I'd like if we could get past it. I'd like if we got past these ridiculously blunt measures of metrics. Hey, we can do that with data, okay? And we can, and we've got to start doing this. Data metrics and alt metrics and all these different things can be done, but it's a cultural change and what we actually appreciate. I'm much more concerned about almost everyone I know wants to do good work, and is less concerned about being evaluated. And I just think if we do that, good things will actually happen. But what we can do is the data science has actually volunteered, and Carl Stamer was pioneering this. We can help evaluate students who you can't evaluate because they're doing different things. So if you're somebody in history, let's just say, and somebody's doing a research that is very quantitative, we can actually help to say that person is not trying to pull your leg and hasn't done anything for the last year. So that can help a little bit.
Yeah, and departments can try to rise to the challenge of actually writing out standards of scholarship that include broader recognition of what counts as production. In anthropology and cultural anthropology, we actually did this, where we defined things like how a book or foreign language publication counts as scholarship in a way in that other fields it might not. And this was partly because as a discipline that really spanned this qualitative-quantitative divide and single author, multi-authored, it became very important to speak across the aisle and establish what the expectations were. And this has all sorts of really interesting effects to actually say that, like, producing a film can count as a full manuscript in our department. Producing a media piece, if it can be evaluated and argued that it's of the length of a monograph. Otherwise, it might only count, say, as an article. But that we can innovate in terms of recognizing that producing software, that actually producing and maintaining a data set could count as fundamental research in history, not just service. But these things take the work to think ahead about this and to actually then start trying to codify it, to recognize it, because in this way you can save the person 3 years down the line when they come up for tenure, and they can point to this document that they saw when they arrived, and contractually speaking, now they're right. This is, it's a kind of an interim solution, but I think it's worth, as we all talk and get excited about new forms of scholarship, to think about where we can also put that on paper that, in our discipline now, this is research. It might have looked like service before, but now it's research, et cetera. Those kind of things, I think, can be really interesting to try to explore. You might meet lots of resistance, but it's then at least the conversation's on the table explicitly rather than implicitly. And especially for junior scholars, having it there explicitly would be a good help, very helpful to them, because they might be getting mixed signals, and as we know, that can cause distress. Time for one more question. Or let's have it offline, and we have a small break.
Till 3:45.
Till 3:45.